So today's lesson, we're doing part 2 of lesson 2, and we're really putting together stuff that we've learned from lesson 1 and lesson 2 involving the mole. So what's on your screen right now is something that I made up called the mole roadmap. It's basically like a map that you would use for navigating from one place to another, just like a map with roads, but this time it's used for moles. So, what are the two types of calculations we've done with moles? Well, we've done one with mass and we've done one with particles. So now what we're going to do is try and put them together. You can probably see by looking at this map, there's no line that directly connects mass and particles. So going from grams to atoms or molecules or formula units. Nothing there. That's because there isn't a one-way step to get from mass to those types of particles. So what connects both of those units are the moles. So if we have a quick look at this before trying a problem, what if I wanted to go from mass to number of molecules? I just need to follow the arrows. My first arrow takes me to moles. That's my first pit stop along the way. So I have to do a calculation. And how do we calculate between mass and moles? Our calculation involves a conversion with molar mass. After I have moles, I can continue on my destination to get to number of particles. I follow my arrow here and I can see I need to use Avogadro's number. That's my relating relationship between moles and particles. For reference, Avogadro's number is right up here on the top. Then there were some questions we tried. Once you have particles, can you find the number of atoms or ions in a molecular formula unit? That's an even extra step, and we need to either divide or multiply by atoms. So as we try out a couple of problems today, we're going to come back and look at the mole roadmap and see if that can help us solve some of the problems. So let's take a look at one problem first. So this problem says, what is the mass of 5.67 times 10 to the 24 molecules of cobalt 2 chloride? So, what are we trying to solve for? We're trying to find mass. So this here is going to be our unknown. We have a measurement given to us, but it is in molecules. That's a type of particle. So 5.67 times 10 to the 24 molecules. Okay, now there's nothing where we can do a simple one-step calculation to go from particles to mass. So let's go back to our mole roadmap and have a look at how we're going to do this. So in this map, we are starting here with our first problem. We have our number of moles, that 5.67 times 10 to the 24. We want to end up here because we're trying to find the mass. So we have to follow the road in the right direction. So we're going to first look at our arrows. This arrow points here. Step 1 means we're going to first have to take our number of molecules and convert them into moles. And we're going to use Avogadro's number. That's one part of our calculation. Once we do that, we'll have a number of moles. Then we can move on to where we want to finish or calculate at mass. This is going to be step 2. Step 2, to go from our number of moles to mass, we need to use the molar mass of the COCl2. So to do our question, it's going to involve 2 calculations and 2 conversions. So for reference on our notes here, let's write down our steps. We're going from number of molecules, which we said was our capital N. And first thing we need to do is find number of moles, which we know is little n. That's our first step. And our conversion for that is Avogadro's number. Next step, going from moles to mass. We know this is going to be our step 2. And we said to go from moles to mass, we need our molar mass. So using your roadmap is good, but you can also kind of make a mini version of your roadmap, especially at the beginning, and kind of trace out what kind of steps do I need to follow to solve the problem. That way you can solve for one at a time and it'll be a little bit less intimidating. So let's go ahead and we're going to try and solve step 1 together. So step 1, we're going to start off with solving for moles. We always start with what we're trying to solve for, and we start with a number that we're given, 5.67 times 10 to the 24. And our units are molecules. And just like everything we've been doing, we're going to multiply it by a relationship. So, looking at our guide here, our relationship is Avogadro's number. 6.02 times 10 to the 23 molecules per mole. So I have molecules and moles for my units here. I want to get rid of molecules. Molecules in the numerator. Molecules have to go in the denominator. I want to end up with moles. Moles should go on the top. Now we can put in our numbers from Avogadro's value. So it's always per 1 mole. And how many molecules? 6.02 times 10 to the 23. So now I'm ready to punch this in my calculator. Make sure again when you're doing a multiplication, division with scientific notation, put brackets in your calculator. So put this number in your calculator with brackets around it. Multiplied by 1 is not going to change anything. But then when you divide it by 6.02 times 10 to the 23, make sure that number is also in brackets. Otherwise, you might get something that doesn't work out. The order of operation doesn't always work out the way you want. You should get a number with a bunch of digits. We're just going to keep a few of them here. So you should get around 9.4186 moles, something like that. So now what we've done is our first step, or our first calculation. We've gone from molecules to moles. We're not done the question though, we want the mass. So now we're going to use our answer from part 1 to calculate the mass for part 2. So we did not get a molar mass in this question, but we know what the formula of our compound is. 1 cobalt, 2 chlorines. So before you go on to step 2, why don't you take a minute, pause, and see if you can find the molar mass. So try this out. All right, let's check what you've got. 129.83 grams per mole is what you should have gotten. So this is going to be our conversion here to help us as we move along. So how do we start the next problem? We start with what we're trying to find, which is our mass, but we have to use our answer from step 1. So that 9.4186 is going to start off this part of the calculation. Then we're going to multiply it again, always by a ratio. So hopefully you're starting to get the idea here. We are going to take moles in the numerator, so that means moles have to go in the denominator. And since we want to end up with mass, the units we want are grams. You can see grams and moles. That relates right over here to our molar mass. Whatever you're converting should always match your ratio with units. So now we can put it in and be specific. So we want to have 129.83 grams in the numerator. Oh, I just wrote grams twice. Let's get rid of that so it's not confusing. And then 1 mole goes on the bottom. So when we do that, we should get an answer of 1,222.817 grams. And again, at the very end, make sure that you round your answer to the correct number of significant digits. So let's just take a walk back up here. Significant digits with something in scientific notation only come from those values there. So here we've got 1, 2, 3 values. So that means 3 significant digits. So we're going to scroll back down. And our answer here, we're going to round to significant digits. So you can either do something like this, 1,220, where the 0 is just approximated. But I usually prefer scientific notation because it leaves a little bit less guesswork there, and that definitely shows 3. So that's how you do a calculation going from mass to molecules. Now, for people who are a little bit more comfortable with math, you can actually combine step 1 and step 2 all together in a one-line solution. So let's say you wanted to try that, and again, this is completely optional. What if you want to combine both steps into one? You can do that with all of your units. So how it would work, you start with your very, very last thing you're trying to solve for, which is mass, which is what the question is trying to show you. So mass, you start off first, then you do your first calculation. Start off with what the question gives you, 5.67 times 10 to the 24 molecules. And then we go through and still do the same step to start with Avogadro's number. So 1 mole per 6.02 times 10 to the 23 molecules. But instead of stopping there, you can put on your next conversion, which is the one with molar mass. So if we take a look at our units, molecules and molecules are gone. And our next one, we have moles on the top. We want to make sure moles go on the bottom and grams go at the top. The very last unit here that doesn't cancel should match what you're solving for. So here you can put in your 129.83 and 1 mole. And then you're ready to solve the whole thing in one step. So if you're trying this mathematically, what you're doing means you're doing 5.67 times 10 to the 24 times 1 times 129.83. And then you're going to divide it by everything in the denominator. Make sure you put brackets around everything in the denominator. So divided by 6.02 times 10 to the 23 times 1. And when you do that, you should still get the same answer. It's the same math, but you've combined the two steps into one. So this part down here, if you want to try it, is completely optional. But if you're a lot more comfortable with math, and once you've tried some of these calculations, it can save you a little bit of time. All right, moving on to the next question. I'm going to see if you can think about this one first. So in this question, we're asking how many formula units are there in 5.984 grams of calcium chloride? So again, a little bit different. Let's write down what we've got and what we're trying to solve for. We can definitely see we have a mass here, 5.984 grams. And they're asking us for formula units. Remember, formula units are a unit that we use sometimes with ionic compounds, but that just means a number of particle. That's what we're trying to solve for here. So let's flip back to our mole roadmap for a minute. Back a couple slides. Let's take a look here. So in the question that we're working on now, this one in the blue was what we were working with for the first example. This time we're starting off with a mass. We were given that mass of 5.984 grams. And this time we're ending over here. We don't know the number of particles. So if you look, the arrows don't overlap. They've got arrows that point towards moles, and then we've got one point towards particles. So the first step here is going to involve converting that mass to number of moles. Same conversion though. When we do that, it's always molar mass. Once we have the number of moles, then we can find the number of particles. So number of particles again, same conversion. We're going to use Avogadro's number. So if we go back to our question, let's make a little note of the steps that we're going to take, and then we'll try and solve the problem together. So first, we're going from mass this time, and we're trying to find moles. This is our first step. Mass and moles, we said, always involves molar mass. Our next step, we're trying to find formula units. Formula units is a type of particle, and we know we need Avogadro's number for that. If you want, for reference, you can put your little symbols in there so you know what you're actually trying to calculate. So I'm going to let you try and do this step by step, so I'm going to ask you to pause along the way. So why don't you go ahead and see you can convert from mass to moles and do step 1 all on your own. And then when you're ready, unpause and check your answer, then we'll do the same thing for step 2. So now you're ready to check your answer for step 1. So number of moles, we always start off with what we're given, 5.984 grams, and we're going to use our molar mass. Now again, did they give us molar mass in this question? No, but you can calculate it. So if you calculated your molar mass, you should find for 1 mole, you should get a mass of 110.98 grams. That's the molar mass for calcium chloride. I'm going to put that up here just for reference. So you can calculate that one. Okay, now that we've got that in there, grams and grams cancel, and we should get somewhere around 0.0539 moles. Now again, if you get lots of digits in your answer, just keep a few so we have the rounding reduced, or just keep the whole thing in your calculator and just write a couple on your sheet. Now that's step 1. Now you need to move on to step 2. So if you haven't tried that yet, pause the video and see if you can do step 2. Let's check what you did for step 2. So we're trying to find out number of formula units, which is particles. We have to take our number of moles from step 1. So 0.0539 moles. And again, multiplying it by a relationship. This one's with Avogadro's number. Moles we want to cancel on the bottom. You know that's 1 mole. And Avogadro's number, 6.02 times 10 to the 23. And our units for particles here are formula units. Now we're ready to get our answer. So in your calculator, multiply your moles by your formula units, and you should get 3.24596. There's a bunch of digits there. We've got a few extra down for reference, times 10 to the 22 formula units. And then if we were finishing off the question, we would round it. So how many significant digits do we need? Let's take a flip back up. Here we've got a number. This one has 4 significant digits. So our answer here should be 4 significant digits. So we keep 3, 2, 4, and then do we decide 5 round up or down? It's going to round up to 6. And there's our answer. Now, I'm going to add on an extra bonus question here because this will help you a little bit as well with some of your homework. So let's scroll back up to the top. What if there was a part B to this question? What if part B asked you, what are the number of chloride ions in your sample? What if that happens? So when we look, our unit of particles here, we know for calcium chloride, that's formula unit. This is a smaller subset. Once we know how many formula units, we could figure out atoms and ions. So what we're basically trying to do here, if we go back to our roadmap for a minute, the question we ended up with over here, we finished step 2, we found our number of formula units, but now we want to find how many atoms, or we could even say ions here, it's not specifically listed. We're trying to figure this out. So basically what we're doing is throwing on a third conversion. How do we go from particles to ions? We need a ratio, and we're going to multiply by the number of atoms, or in our case, we're dealing with ions. It's going to be the same thing. So that extra bonus question we threw on to our last example is tying in that last part of the roadmap. So let's go back to the question and try that out so you can see how something like this would work. So we've got this many formula units. So we want to know how many chloride ions are in our sample. So how do we do this? We need to look at our formula here to get one more ratio relationship. For every 1 calcium chloride, so for every 1 formula unit of calcium chloride, how many chloride ions do we have? If you look in the formula, you can see there's Cl2. That means there are 2 chloride ions in there. For 1 calcium chloride, we have 2 chloride ions. This is going to be our conversion factor. And we know we can write ratios as fractions, which is what we're going to do to try and solve the problem. But to do that, we need our answer from above. And we're going to use that unrounded answer here to eliminate some of the error. So let's just readjust this here so we can get everything in there. So now if we're starting off, this one doesn't really have a symbol because it's just asking for chloride ions. So how many chloride ions do we have? Take our number of formula units, that's our number of particles. I'm just going to shorten that there. These are lots of big units, formula units. And we're going to multiply it again by a fraction, but we're going to use this ratio. I have formula units on the top here. That means formula units have to go on the bottom. And then ions is what I'm solving for. That's going to go on top. So how many formula units? Well, 1 formula unit of calcium chloride gives us 2 chloride ions in it. So now we can see we're taking our number of particles, formula units, and multiplying it by how many chloride ions there are for every 1. So now when we do that, we're going to basically double our answer. So when you do that, you should get 6.492 times 10 to the 22 chloride ions. And that's already rounded to significant digits there. So the question's saying in our sample, we have this many formula units or this many calcium chlorides. How many chloride ions specifically are in there? For 1 calcium chloride, I have 2 chloride ions. When I have this many, I should have a lot. The ratio is 1 to 2, so we've got this really big number down here. So hopefully that helps understand a little bit more about converting between mass, moles, and particles. This one's probably one of the trickier things to get your head around. So just make sure you practice a lot, post any questions that you have, and reach out for help if you need it.